We're looking at comparing distributions for quantitative data. And if you opt to do it with histograms, these are going to end up being separate because they can't really be put on the same graph. The only thing I can think of would be to make this flip upside down and put it underneath this one, which I think would just confuse people. So what we have here is average wind speed in miles per hour, and they're comparing winter and summer. It's as though they've made two categories out of a year, and they've charted some average wind speeds in the two particular seasons. So when you're looking at these things, you probably should, by the way, you should title this. So it's a little hard to figure out without the title, hence the reason why I ask you to do it. You need to comment on CUS, center, shape, unusual characteristics, spread, those kinds of things. You need to do those separately for each one, and then compare the two with meaningful words like it has a higher mean of such and such compared to a lower mean of such and such, or median, or one has more spread than the other has. You use qualifying words like that, greater than, more, So in looking at these, clearly summer is going to be skewed to the right. And when you look at winter, a lot of the kids in the class just went with uniform. I'm kind of all right with that. It does have a little bit of a drop off to the right. It does seem to have an extreme, it has a few days at 7 miles per hour, a little bit of a gap there, but in any event, they're different. So you would probably want to go with medians, especially since this one for summer is skewed to the right. IQR for spread. And so in looking at this, it's easy to think, well, there's just higher wind speeds in the summer because this is tall. But keep in mind, this is frequency. So this is the tallest, and and this is the next tallest, and this is the third tallest, and really most of your days are just 0 to 2 miles per hour, which is not much wind. It's almost like still air. But now here, this has a lot of action going on above 2 miles per hour. So to me, it looks to me that winter is the windier of the two times. And you can probably find that if you compare medians. So that's kind of what it tells you. So you can throw a whole lot of box plots into a single graph, and here they are. There's 12 of them. There's one for each month, and we're looking at wind speeds per month, and we can compare them. Now, when I do my side-by-side box plots, I like to have 2, maybe 3 max, because I like to drill down a little deeper. And I do prefer them horizontal, but in a case like this, vertical is fine. But the thing is, if you try to pair these up and compare them, there's like an endless number of pairs. So you're just going to have to kind of follow along with a major feature, like perhaps median. This line is your median line in the middle of the box or inside the box. And you can see these are some of your colder months, although it is warming. And it looks like you got more wind speed going on here. Here's some more colder months. Those have a little bit higher median wind speeds compared to summer. Summer is looking like it's basically lower. You can almost see the U shape in it if you just kind of look at the medians. They have put outliers in, and I'm guessing, I don't know, either that's a mistake in the graphic or it's just extreme, although I've never seen anybody kind of differentiate between a regular outlier and an extreme. So let's just call that one a glitch. All right, this is just something that we saw yesterday on Thursday. Speaking about outliers, if you've got them and you're using mean and standard deviation, go ahead and pop those numbers out with the outliers present. Take them out, recalculate the mean and the standard deviation, and then go ahead and comment on differences or changes. You definitely should see changes. median and IQR are used for clear outlier situations, skews, because they're not likely to be affected. They're resistant. All right, time plots. Time plots are an AP requirement, so I am going to present them to you, but I don't think we'll see them in any homework. They're pretty simple graph. They're really a scatter plot, and this is the same wind data. So here are average wind speeds, and these are just the day of the year. So right here would be like January 1st, somewhere right around there. And here is 365 days later. So in commenting on this, you can see a dip into summer and then a rise again after that. So we're looking at colder months here, colder months here. In general, we're looking at higher wind speeds than in the summer. And another thing that you can comment on is in the colder months, you're seeing much more variation. See the spread here? Spread here is even bigger. And not so much spread in the warmer months. So you can comment on that too. Time plot. Whatever you're measuring over time. And by the way, that all of those vertical box plots, one per month, that was doing pretty much the same thing. Funny cartoon. Okay, so I guess, many people think that statistics are just ways to bend numbers into an agenda. In other words, to make the numbers lie. And that's a little bit of a problem for us as statisticians. Our job is to just gather the numbers, analyze the numbers, and report what's there without throwing in any kind of personal agenda item. So a lot of times newspapers, magazines, websites, broadcasts will throw up graphics to try to get some statistical idea of a trend across, and they're just going to be really not so great. So looking at this one, it's even hard to tell what they're measuring here, but this black line is the rise in tuition from 1965 to 1999. This kind of orangish red line is Cornell University's ranking, and even this is not consistent for a scale because this starts in 1969 as opposed to 1965. So the scale is off. And plus, if you're measuring tuition, wouldn't you be measuring that in dollars? And if you're measuring a ranking, well, that's some kind of ranking units. I wouldn't know quite what they are, but that's not dollars. So you've got two things that are measured two different ways in the same graph that don't even start in the same, they're not in the same time period. They end in the same time period, but they don't start in the same time period. So I guess what's happening here is they're just trying to convey that tuition goes up, the ranking goes down, and I guess people will get it, but statistically, that's a pretty shabby graph, and they get worse. And I suppose what even bothers me more than this is this big tall building with the point at the top. Like, it's giving me the sense that something is growing, and it's just a building. Like, you don't want to decorate your graphs with buildings or airplanes or fish or, because I've seen graphs where some kind of big quantity is shown with a great big airplane, like a cartoon airplane, and some small quantities are shown with little bitty cartoon airplanes. So, yeah, don't do anything like that. All right, here's something else that can go wrong. These are three box plots in the same graph, and I'm looking at these two and I'm thinking, yeah, where's the boxes? I think these little pointy things, like those prickers that get into your feet whenever you walk through grass down here, those must be outliers, I guess, but who knows? There's no box here. So my thought is that this scale is wonderful for this guy, the smoker, but for the other two, not so much. I think maybe you should put these in different scales, or at least maybe put these two in a different scale as opposed to this one. By the way, I did pose the question to the group, can you have a missing whisker? See how this bottom part is missing a whisker? And most people said no, but that's not so. If you're lower quartile, which would be your lower 25% would represent, would be represented with data. It could be like a 20, but you could have like 20 of those 20s, so that the minimum in the Q1 could end up being the same number. So yeah, you can be missing a whisker. You can be missing both whiskers. That can happen. Not much, but it could happen. All right, so to summarize, comparative graphs are pretty useful. They do expose situations where things are going on that you might not realize. So they're good for exposing patterns. Box plots are particularly good, and I'm going to show you an example of one momentarily in the packet. Don't forget that outliers are a big deal. I mean, you can just find them and plot them, but you really ought to call attention to them and perhaps think about them. What are they doing there? Is it an error on your part? Are these just unusual individuals that maybe shouldn't be in your study, or should they stay? You should just spend some time with them. And they will affect your number summaries. And don't forget, we did the time plot and we did the comparative box plots, the side-by-side, to see changes over time. Those are pretty much eye-opening. And just a couple of AP tips, and these are good tips. Well, I guess maybe it's just one. No, it's two. This is something I'm going to look for when I grade quizzes and tests too, because if the AP people want this stuff, then I have to want it too. Remember, when you're looking at comparative graphs, compare the distributions for center shape, spread, and all three are required. For credit, unusual characteristics probably should be there too. And when you're comparing center and spread, use meaningful words. Like, if you just say the mean was 34 miles per gallon in group A, while the group B mean was 30 miles per gallon, you don't get credit for that. I mean, you're probably correct, but the AP people want you to communicate the fact that 34 is a bigger value than 30. Or, if you don't like larger, you can just say 30 is the smaller of the two. So that'll give you full credit. So use those qualifying words. Larger, smaller, greater, more variable, anything like that. All right, this is the homework, and I'm going to now close this out and refer you to your packet. And whoops, that's not your packet. And this may be a different page number. I do think it is 23 and 24, but it's the notes for comparative quantitative graphs. And this is a baseball study on home runs. And here are all of the home runs hit by Babe Ruth in his years with the Yankees. And there are a lot of years and a lot of home runs. And here's Roger Maris. And here are his home run totals playing for the Yankees, right? The issue here is that back when baseball was kind of a young sport, there were a lot of slap hitters and a lot of singles hitters, and walks were considered a great thing just to get on base any way you could. And then along comes Ruth, and he starts whacking home runs, and he sets this standard at 60, which lasted a while. And it was believed to be an impossible record to break. Until along comes Maris, and he has a season where he hits 61. That was in 1960. I can't remember the 60 home runs back in the 20s or 30s or so. So there was a big, long time period in between. All right, so here are your 5 number summaries, and here are these comparative box plots. You notice that there's 2 of them. They're labeled with the categories, and they're horizontal. I personally like that, but if you have more than 3 or so, you probably ought to go vertical. Scale, title. Okay, so if you just compare medians, Ruth has a higher median, all right? And I did mention that. Maris is skewed to the right, which means a lot of his seasons with the Yankees, he didn't hit a whole lot of home runs. Ruth's is pretty symmetric, okay? And, Maris has a minimum that's below 10. Ruth never had a season below 20, all right? But what I want you to just think about is, if you just remember what a box plot is, from this whisker to Q1 is 25% of the years we graphed for Maris. Here's another 25. So that's your 50th percentile, meaning that 50% of his years are below that value. Here's Q3, which is 75th percentile, and here's your maximum. And he wins for the maximum. It's higher than for Ruth. But do you see here, this is Q3. So Q3 is 75th percentile, 75% of the years in the study were below this mark. And this is Q1 for Ruth, which means that only 25% of his lowest years for home run hitting with the Yankees occur here. And what's neat about this, and you can't always draw this comparison with every situation, but you can here. You have Q3 for Maris almost lining up with Q1 for Ruth. So overall, you can make a statement based on those quarterly analyses. You can say that right about at the same place lie Roger Maris's 75% of his worst home run seasons with the Yankees, and that compares to 75% of the best of Ruth's above that same basic split right there. So I wrote down here, one might conclude the upper 75% of Ruth's production occurs around where the upper 25% of Maris's home runs production occurs. So basically, Ruth is a far better home run hitter. If I could pick either one of these guys for my team, I would pick Ruth. And if you go back up here, the guy was kind of crazy good. 60 for one season. He almost did it again. There's 59, 2 seasons of 54, a lot of seasons at 45 or higher. And Maris, he had several pedestrian seasons. Here's 8. Here's 13. Here's 14. Here's 16. That's a kind of a weak home run hitting season by today's standards. So while he did have one shining year, he is by far not the best home run hitter compared to Ruth. Okay? Okay. You can also put stem plots in the same graph if you're dividing up between two categorical variables. And here we've got them. These are heartbeat rates for women. There's a bunch of those. Here's heartbeat rates for men, a bunch of them. And I just set it up in a stem plot. So if you look right here to the right, these are the stems, and the leaves to the right are the males. And that's like a typical stem and leaf graph. And so I gave it a regular legend. But you can use these same stems and fill in the other side for the females, right? So in order for this to make sense, you probably should put a second legend in so your reader can understand it. All right, so 5 number summaries, IQR, and you can go ahead and actually count the median for both. Or if you want all the number summaries, just put them in your calculator. All right, females had a larger median than males, all right? And if you look, just glance at this, aren't the females bunched up here in the higher stems, and your males are bunched up here somewhat, at the lower stems? So it makes sense that you would see women have a higher heart rate, just, kind of according to this. And it's true. And biologically speaking, women do tend to have a higher heart rate than men. All right, so then your interpretation for shape. You can go ahead and rotate your view and just kind of look at it and make it a little bigger. I can get this to come back up. There you are. All right, and here's your males. And you look at that, and I had some people, yeah, it's skewed right. I had some people say, yeah, it's skewed left. But looking at it, isn't it approximately mound-shaped? I mean, I would go with your skews if you said slightly, but really this thing is pretty mound shaped. You know, not perfectly symmetric, but okay. So now I'm going to rotate it back. So this should go clockwise. And I'm going to keep going clockwise so I can get the females on the top here. All right, so there's the females. And you have to be careful because this has a skew. And you're going to look at it and you're going to say, ooh, skewed right. And visually, that would be correct. But what you're doing is you're ignoring this scale for your stems. Because a regular scale should go from least to greatest. This is actually the wrong way. This is greatest to least. So what you're seeing here is a mirror image. If you could draw a mirror right here and reflect this over, then you would see that it's skewed to the left. So that is a feature with these things. All of your values that are on the left, when you go to analyze them, you know, the direction of the skew is reversed. Not so much for the regular side, but for the new side that we just added on for the second categorical variable. Yeah, that thing is definitely, oh, I keep making this mistake. That thing is definitely reversed. So let me get this back if I can. All right. Hold on, I got to sneeze. God bless me. So there it is. There's your comparative graphs. We're doing this with quantitative data. Remember your categorical data had comparative pie charts or segmented bar graphs, and you know you're looking for just differences in proportions mainly. So I'm going to call it on that. We're done. And we'll just go ahead and see you next time. Don't forget the homework. It's on your calendar.